Hi, I'm an old guy and I do maths, and today we're looking at residual graphs. Somebody who knows a little bit about them might be forgiven for asking, why are we not looking at one? Well, we will be looking at one in a minute. In fact, we'll be looking at two. But residual graphs are graphs of residuals when you are working with linear regression and lines of best fit. So the first thing that we are going to look at is we're going to look at a line of best fit, which is here in red, and the actual data points scattered about that line. And a residual, if you don't know what it is, there is a video in this playlist on this, but very quickly, it's the distance between here and here, or here and here, or here and here. And those distances can be graphed. And this is what the graph of the residuals on this graph look like. So this one is here, it's positive. So the point about a regression graph is that it has a midpoint of 0. And what we're looking for is we're looking for not only the distances between 0 and these points. So zero distance would mean that there's a point on this line. Obviously there is a distance here, and that's reflected in this point here. So this point here becomes this point here, this point here, this one, and so forth and so on. And their distances are reflected in the scale up here. And because there's no scale on here, I haven't put a scale on here, because that's not actually the important thing. Now, it's the way in which these things present themselves on this residual graph that tells us something. Now, what you'll notice is two things, hopefully, that there's pretty much an even number of data points above and below the line, residual points. So there's 4 down here and there's 4 up here. That's kind of important. It's one of the important things. The other thing is that there's no discernible pattern to this. It's just a collection of dots. You can't see something that looks like that. It doesn't appear to be doing that. It's just running along with dots either side of the zero line here, and no apparent pattern. What that tells us is that these represent the residuals from a linear plot. So what that means is that you don't have to undertake a transformation. You don't have to look at the circle of transformations and go, oh, I need to try a log x transformation and see if I can linearize the data. That's what this is all about. Now, if we turn this page over, what we have is another pair of plots. And what prompted me to make this video was that there was a question that I saw in an exam that looked, this is a little more exaggerated than it was, but it looked, the data points looked like this. And what you have is you have a couple of data points there, a couple of data points there, and 4 down here. So there's an even number over here and an even number over here. And that translates also down here into this pattern where you have 2 here and 2 here and 4 here. Now, you'll remember that on the previous graph, I said that having an even sort of a distribution is one of the things that you look for, but it's not the only thing. What becomes apparent when you graph these residual the residual plot onto this graph is that you have a pattern, and it kind of looks like this. And you can see it. You can see that there's a curve to this. And what that tells you is that the data up here is non-linear. Now it's a little bit obvious here. It wasn't so obvious in the exam question. It was much more subtle, and you really didn't see it until you did this. So this is the test for whether or not data is linear. Now, what do you do from here? Well, if you're looking at this sort of thing, you will have seen the circle of transformations. And what you do is you go to that circle and you find a pattern that fits with what you see here. So this might be an x squared one, for instance, which you would read off that chart. And then in order to linearize this data, what you would do is you would submit it to an x squared transformation. You do so using a calculator nowadays. The days of doing this manually are gone. And what it would wind up doing is it would wind up making this pattern look much more like the pattern that we saw previously, and it would you could then retest it and see if there's a discernible pattern of dots. And if there isn't, if the set of dots that you get looks like this, so sort of generally scattered about evenly either side of this line, then you've successfully linearized your data. Okay, so I hope this was helpful. It does cause some confusion, but that's it in a nutshell. You're looking to check whether the data is linear or non-linear, and it then gives you a cue as to what you do with that. So, as I say, I hope it was helpful. If it was, please like and subscribe, and I'll see you next time. Bye.